Okay, guys, so today in math we are on lesson 3, which is going to be the use of exponents to name place value units and explain patterns in the placement of the decimal point. So before you watch this video, I want you to go watch the first video that I had posted that says Eureka Math Module 1, Lesson 3. Once you watch that, then come back to me if you haven't already. And this video should pick up kind of where he is at. Now, we need to talk about that word exponents. It says use exponents to name a place value, but we don't even know what exponents are. So on a blank sheet of paper I have gotten out, I'm going to write just a couple notes to help me remember kind of how this is all going to work. So I'm going to write exponents. And then I need to know what an exponent is. So I looked up the definition. It says an exponent is a way to represent how many times we use 10 as a factor. So I'm going to write that. It's a way to represent how many times we use 10 as a factor. Now, I'm going to give you an example of what I mean, okay? So if I have the problem 10, this is an example, I have the problem 10 times 10. Well, I know that 10 times 10, if I were to do the math or if I were to look it up by using a calculator, you would figure out that 10 times 10 equals 100. Okay, now I want to know how to write 10 times 10 as an exponent though. So if I said it's a way to represent how many times we use 10 as a factor, well, let's count. We used it one time here and one time here. So we've got a total of 2 times. So 10 times 10 is you can say 10 times 10. Another way to write that would be 10 to the second power. Okay, and our 2 would go right up at the top, and like I said, you would say 10, this is 10 to the second power. Okay, so our powers, our exponents are always going to be the little numbers up to the top right of our big numbers. So this is our main number, this is our power. That's our exponent. So 10 times 10 equals 10 to the second power. Now, it told us, I'm sorry. So 10 times 10, it told us how many times we used 10 as a factor. We used this 10 to the second power, we used it 2 times. 1, 2, okay? An easy way, I'm gonna write this, easy way to know how many times we multiply by 10 an easy way to tell us how many times we multiply by 10 is either counting, the zeros, or looking, looking at the exponents. Okay? For example, we just said that 10 times 10 was 10 to the second power. Well, if we were looking at our zeros, like it says, counting the zeros, if we looked at this problem, we have 1 0 right here and another one right here. Well, 1, 2 should match here. So the amount of zeros that you're multiplying by should match the amount of exponents you're using. Now, to check that, if I were to look at the exponents and not look at the zeros, if I said 10 to the second power, well, I would know that I would need to be multiplying 10 at least 2 times because it needs to have 2 zeros. I looked at the exponent says 2, so I need to come back and find the 2 zeros in the problem. So let's do another one. If I said, example, 10 times 10 times 10 times 10 equals 10. We need to figure out the power. So 10, we need to figure out what 10 times 10 times 10 times 10 equals to the power. 10 to the equal what power? So we can look at 2 ways. We can either count the zeros right here, or we can look at the exponents. Well, right now we don't have an exponent to look at. So let's look at the zeros. Let's go ahead and count our zeros. 1, 2, 3, 4. Okay, so we counted our zeros, 1, 2, 3, 4. We multiplied 10 4 times, 1, 2, 3, 4. So I'm gonna say that 10 times 10 times 10 times 10 is 10 to the 4th power. Now, if we did that math and we multiplied this, if you want to check it on a calculator, you would get the answer. If you typed in 10 times 10 times 10 times 10, you should get the answer 10,000. Okay? And the same thing, if you were to type in 10 to the 4th power, it would also come out as 10,000. Now, this is another place we can count our zeros. So this amount of zeros should match this amount of zeros. So to check 10 to the 4th power, let's look at here. 1, 2, 3, 4. We have 4 zeros in 10,000 and 4 zeros across here. So 10 to the 4th power equals 10,000. If we came back over here, 10 times 10, well, we want to do, if you type this into a calculator, you would get 100. 10 times 10 is 100. If you count your zeros, 1, 2, and they match your exponent, then 10 times 10 equals 100, which also equals 10 to the 2nd power. Okay, so let's look at it on our place value chart. So I'm going to draw a place value chart that goes all the way across my paper. Okay, and I'm going to put 10, 100, 1,000, 10,000, 100,000, and 1 million. Okay, I'm going to separate all of these. Okay, so how do I get 10 if I multiplied it? 10 times what is going to equal 10? Well, anything times 1 is always going to equal itself. So I know this equation right here is going to be 10 times 1, because 10 times 1 is 10. I only have 1 0 here, so I would say this problem with an exponent would be 10 to the 1st power. I only have 1 0. I multiplied it by 1. Therefore, it is 10 to the 1st. 10 to the 1st power. Now, if I were to move on and go to 100, Well, we set up here 10 times 10 equals 100, or 10 to the second power. We're going to bring that same thing down here. Let's count our zeros. 1, 2. So that's how many times we need to multiply 10 by. 10 times 10. And then down here, our exponent is going to be 10 with how many exponents? We'll just have one exponent, but what number exponent will it be? Let's go up here and count. 1, 2. Therefore, it is 10, 100 is 10 to the second power. Okay, moving on to 1,000. So we're at 1,000. We're going to go 10 is 1 0 times 10 is another 0 times 10. And we have crossed out all of our zeros. So we now need to find our exponents, which means we need to count these all up. 1, 2, 3, 10. 1,000 is going to equal 10 to the third power. Okay, we come down here, or over to 10,000. Let's go through and start doing our 10 times. 10 times, that's 1. 10 times, that's 2. 10 times, that's 3. 10 times, it's 4, equals, let's go through and count so we can find our exponents. 1, 2, 3, 4. Therefore, our exponent is going to be 10. It's going to be 10 to the fourth power. Okay? And then we have 100,000. We are going to start doing our 10 times. 10 times, 10 times, 10 times, 10 times, 10 equals, well, let's go through and count. 1, 2, 3, 4, 5, which means this is going to be 10 to the fifth power. Okay, and our last one is going to be 1 million. So we're going to start with our 10 times, 10 times, 10 times, 10 times, 10 times, and 10 equals, let's go through and count. 1, 2, 3, 4, 5, 6. Therefore, 1 million is going to equal 10 to the sixth power. So no matter what, if you were to type into a calculator 10 to the first power, what your answer that's going to pop up is 10. The equation for that is going to be 10 times 1. If you were to type in 10 to the second power in a calculator, your answer would be 100. And your equation for that would be 10 times 10. If we come here and we type into our calculator 10 to the third power, it would come up, your answer, 1,000. And to get 1,000, your equation would be 10 times 10 times 10. If we typed in 10 to the fourth power, your answer would be 10,000. And your equation for that would be 10 times 10 times 10 times 10. So on and so forth. So this is creating a pattern. You have created a pattern. Every time, you're not just adding 1, and you're not just adding 10, you're multiplying by 10 each time. So you're multiplying by 10 every time, and every time you multiply by 10, you're going to add another 0, which then adds another power. So every time you multiply by 10, you're going to add another power. So if I started at 3 and I multiplied again by 10, then it would move up and I would have 4 because I multiplied it 4 times instead of just 3 times. So let's look at our problem set. Okay. You should be on page 21 in your book. I'm not going to do all of these with you. I'm going to do the first couple and then we'll kind of go from there. And I may just skip around and do some and not the others. So it wants us to write the following in exponential form, which means we are going to use exponents. So in A, B, C, D, E, and F, there are no exponents. It wants us to find the exponents and put them in there. So we said one way, according to our notes, is we can count the zeros. So I'm going to use that. 1, 2, 3, 4. Well, there's 4 zeros in 10,000, so I'm going to assume that it is 10 to the 4th power, which means I did 10 times 10 times 10 times 10. And if I were to multiply all that out, I would get the answer 10,000. I multiplied 10 4 times, 1, 2, 3, 4, and got the answer 10,000. So this one is correct. Okay, now let's look at C. I'm going to skip B and I'm going to look at C. Now, we don't have exponents, but we can count our zeros. 10 times 10. Well, we know there's 2 zeros, which means if we multiplied 10 times 10 and you counted your zeros and put them together, you would get 100, which would then be, erase that. It wants it in exponential form, not in regular form. So we have 100 right here. We need the exponent for it. So we said there's 2 zeros, so 100 is going to equal 10 to the 1, 2, the second power. Because we counted 1 10 right here and 2 10s right there. Okay, let's look over here. We're going to look at D. So this one's kind of tricky because we've been talking about 10, not 100s, but we're going to break this down. So if I were to split 100 into 2 10s, because 10 times 10, we just said was 100, and then 10 times 10, well, now we have it broken down simpler. So we have 10 times 10, which equals 100, times 10 times 10, which equals another 100. So if we count all of these up, 1, 2, 3, 4, we have 10 to the 4th power. Okay, now let's go down here. 1,000. Instead of counting and doing like we just did and breaking this up, I'm going to do it by counting the zeros. So I'm going to say 1, 2, 3, 4, 5, 6. That means I have to have at least 6 zeros in my answer. So 1, 2, 3, 4, 5, 6. Well, 1 times 1 is 1. So 1, we're going to get 1 million right here. Okay. So 10, we said we had 6 zeros. 1, 2, 3, 4, 5, 6. We get 6 zeros, which means it is 10 to the 6th power. Now, I want you to go back and do B and E by yourself. And then you're going to do that after this video. Right now, I'm coming down here to the bottom, or to the next part where it says write the following in standard form. So it's given us the exponents, and it's kind of got some decimals in here, but we're not going to panic. We are going to figure out what the actual number is that it's being multiplied by. So we know 10 to the 3rd power is going to mean 10 times 10 times 10. Okay? Well, it's also multiplied by 9. So 9 times 10 times 10 times 10. If you were to put this into a calculator and you were to multiply 9 times 10 times 10 times 10, you would come up with the answer 9,000. And an easy way to figure that out is I counted the zeros, 1, 2, 3, and I added 3 zeros to 9 because I multiplied it by 10 3 times. So therefore our answer is 9,000. Okay, now let's come down here to divide. Let's do C. Now remember, if we're dividing, we're making the number smaller, whereas multiplying, we made it bigger. This time we're making it smaller. So we're going to write 7,200 divided by 10 divided by 10. Now, I divided it 2 times by 10 because our exponent tells us that's how many times we're going to divide. Therefore, I knew 7,200 was being divided 2 times by 2 tens because it says 10 to the second power, I'm sorry. So if we said we were counting our zeros with multiplying and adding that many zeros to multiply, if we're dividing, then we need to take that many zeros away. So we have 10 and 10. That's 1 0 here and 1 0 here. Well, I'm going to come back to my 7,200 and I'm going to take 2 of those zeros away. And now I'm left with 72. Okay, because remember, when you're multiplying, you're making it bigger. When you're dividing, you're making it smaller. So that's one way that you can check. Is this number bigger or smaller than this number? It's smaller. I went down. I did what I was supposed to. Now, I want to look over here at the decimals. We've been talking about decimals last week as well as this week, and I'm going to show you how we're going to do them. Now, we don't have room to draw a big place value chart on here, and I don't have the time to do that. So what we are going to do is the shortcut method, and we are just going to move our decimal when it's needed. Okay, so we're going to do 1 multiply and 1 divide and go from there. So if I were to look at letter E, 4.025 times 10 to the third. Well, I'm going to rewrite that, 4.025 times, and instead of writing 10 to the third, I'm going to write times 10 times 10 times 10. Because remember, this exponent told me I was multiplying 10 3 times. So when I multiply, I make the number bigger, which means this decimal is going to jump and make this number bigger. So it's going to jump 3 spaces, okay? It's going to jump 3 times because we're multiplying it 3 times by 10. So we're going to move it once, twice, 3 times, which means we are left with 4,025 with a decimal at the end. Okay, because remember, when we are multiplying, we are getting bigger. When we are dividing, we're getting smaller. Okay, so our decimal moved to the right. Now let's come down here to G. We are looking at 72.5 divided by 10 divided by 10. Because remember, our exponent tells us how many times we're either multiplying or dividing, and this time it says we're dividing it 2 times. Okay, so we know, we just said, when we counted up here, we counted 3 tens, which is how many spaces we moved to the right. Well, this time we're dividing, so we're moving that decimal to the left, which means this number the decimal is going to jump 1 time, 2 times, which means you are going to be left with 1 time, 2 times, 0.725. Okay? So I don't really want you to worry about 3 and 4 today. What I do want you to worry about is B, E, up at the top, and B, D, F, and H on this page. And then any of the other, let me see what the next page looks like. On page 22, I want you to try and work problem 5, A through E, and we're not going to worry about F, G, or number 6. So let's work on those, and then we will go from there. If you have any other questions, please let me know. I hope y'all have had a great day. Bye.